Hi, students. Mr. Murphy here, talking over some very important science concepts regarding the greenhouse effect, global climate change, as well as the ozone layer. These notes, or this slideshow, is going to go with your notes that I printed off physically because I like hard copies. Everything is on Schoology here. You can also fill it out digitally if you watch my directions video that was at the top of your Schoology page. I kind of showed you a little trick to have two windows open at one time so you could watch this and fill out your notes digitally. Like I said, guys, I don't mind if you print it off and fill it out hard copy like I'm going to do with you here, or you do it on the computer. And away we go. All right, so mini unit. I call this the greenhouse gases mini unit. It is usually we would do it in the normal model, probably like 4 or 5 days. We're only going to spend about 2 days in class on it. So everything that we do on this note sheet, it is super important because we don't have that in class time. So I got 4 goals. Okay, so number 1, what is the greenhouse effect? I want you to know that. Number 2, why is the greenhouse effect so important for life on Earth? Number 3, what's a greenhouse gas? And then number 4, how can humans impact the greenhouse effect for better or for worse? Well, the first note we're going to fill in, and I think we know this. I hope we know this. As I'm searching for a pen while recording a video lesson, the main source of energy on this Earth is this wonderful thing known as the sun. And where does this energy received from the sun go? Common misconception for thinking, all right, all the sun's rays just sort of like, I don't know, hit our atmosphere, bounce it off, stick to Earth, who knows? I've been teaching in 7th grade for 8 years, and I can tell you for a fact that not everyone knows exactly what happens. So we're going to split up the sun's energy into kind of 3 parts, approximately where all this energy goes. So energy from the sun is going to be distributed 3 main ways when it strikes our planet. And these 3 things on the sides here, guys, and I'll use my really fancy, super cool red highlighter. Oh, look at that. How cool is that? Well, really neat. Look how sweet this is. Okay, cool. These 3 things, guys, and I'm going to, of course, now delete that because I made a mess of it. These 3 things, guys, are going to be what you're going to write on your note sheet down here to the left. So anyway, 20% of it is actually absorbed by Earth's atmosphere. We talked about our atmosphere last week. Our atmosphere, think of it as a tent in the woods. It's going to keep some good stuff in, some bad stuff out. So in this case, that heat is going to be absorbed by our atmosphere. 30% is going to be reflected back from the atmosphere or surface. It's going to kind of go back out into outer space. And then 50% is actually going to be absorbed by land and water. So again, in terms of what notes you're going to be taking, I want you to add, look at this sweet arrow. That's the arrow of adding onto your notes. Check it out. Those 3 things next to your pie chart. So we talk about 30% of energy is reflected back into the atmosphere, and it's reflected by clouds, atmospheric particles, Earth's surface. And I like this little photo here because you're going to see, like, I like these little sun rays, and it seems like they're almost bouncing off the planet because that atmosphere is going to protect us. 20% is absorbed by the atmosphere. And 3, about 50% of energy is actually going to be absorbed by Earth's surface, both land and water. If you notice, those sentences will be what you write down again on right there. Cool. The greenhouse effect. I'm putting a star here. It's so important. Sometimes common misconception I have kids go, Mr. Murphy, the greenhouse effect isn't important. To which I'd say it is super important because it's one of the reasons why life can exist on this planet, because our atmosphere is able to trap in heat from the sun. It doesn't trap in all the heat, that would be no good, but it is going to trap in some. And raise your hand if you've ever been in a greenhouse. Okay, I've been in one. And I'm going to draw this wonderful picture right here. A greenhouse is usually made out of glass. And you like my drawing so far? This is me hanging out in the greenhouse. See, that's me. Let's get a smiley face going. Okay, cool. Usually, there's going to be plants growing in the greenhouse. Super squiggly plant. I don't know what this squiggly plant would be called, but I don't know, your imagination. Anyway, energy from the sun. The sun's chilling up here. Obviously, the sun is going to need a smiley face too. But energy from the sun, boys and girls, is going to enter this greenhouse. And what's going to happen is heat is going to be trapped inside that greenhouse, just like it happens in Earth's atmosphere. So imagine energy from the sun is coming into Earth's atmosphere, and some of that heat is being bounced back into space, but some of that energy is being absorbed. Because that energy is able to be absorbed inside Earth's atmosphere, the greenhouse effect, we are able to have these temperatures and environments, ecosystems that are capable for life to exist on other planets. We talked in class about Venus. Well, Venus is full of these really thick, I'm going to call them thick. This atmosphere is very thick and it's full of greenhouse gases. And we'll talk about greenhouse gases in a second. But what happens, we talked about Goldilocks, is on Venus, too much heat is trapped. On Mars, not enough heat is trapped. On our planet, because we have this thing called the greenhouse effect, is energy from the sun is trapped, and therefore we are able to be warmed by the energy from the sun. Greenhouse gases, those are the gases that actually trap in that heat, and we'll talk about more about it, make life possible on our planet. And you don't need to write this down in your notes. I already have it folded, kind of chilling down here. Let's organize that up. Okay, cool. It's a natural process. It warms the surface of the Earth. Without it, the Earth's surface would most likely be covered in ice, and temperatures would be close to minus 18 degrees Celsius. And I'm reading that really fast because you need to understand, guys, just like I just mentioned, Mars, which we've talked a lot about, really hot during the day, really cold at night, because it doesn't have an atmosphere thick enough for the greenhouse effect to take place. Venus has an atmosphere that is way too thick. Therefore, all those greenhouse gases, it's like 96% carbon dioxide, are going to make that planet's temperatures like 400 degrees Fahrenheit every day. Earth has an atmosphere that contains a little bit of greenhouse gases, and because of that, those are able to help warm our planet and allow for life to exist on Earth. So what are the greenhouse gases? These are our three main greenhouse gases, and these are the ones that I'm writing in here, I'm annotating. They basically trap in heat! Exclamation point. So the three main ones, and I'd like you to write them down, are carbon dioxide, methane, and nitrous oxide. And we also got to talk about water vapor. That's a greenhouse gas. First, and this is where you take a good amount of notes here, right there. Well, it's naturally formed, and this is where you'll start to write here on your notes. But it is produced by the burning of fossil fuels in automobiles, power plants, and factories. It is a naturally formed gas, but human beings contribute to the amount of CO2 in our atmosphere, and we do that by burning fossil fuels and kind of caring about our current lifestyle. Since the Industrial Revolution, we've produced a lot more CO2 into our atmosphere, and we'll talk about how that might be negatively contributing to global climate change here shortly. But CO2 is also our most abundant greenhouse gas in our atmosphere. And when I say most abundant, you know, because we've talked about it in class, it is the most commonly found. And I think, if my memory serves me correctly, we're talking about only 0.03% of our atmosphere is CO2, and it is super duper darn important. Methane. I like methane because it comes from cows, and I'll teach you in class that it comes from cow burps and cow farts, but that's another story for the future. It is the most potent of greenhouse gases. That is the most efficient at trapping in the sun's heat. It's going to come from, it is naturally occurring and produced from animals, wetlands, and decaying material. This little portion is what I would like you to write down on your notes. It is also kind of naturally produced by landfills. And again, we kind of start talking about how human beings impact our environment. Well, the more fossil fuels we burn and the more trash that we create is going to add more of these natural gases into our atmosphere, and is going to have a negative effect on the amount of these gases in our planet. And the lastly is something called nitrous oxide. I'm on the back side now of my notes, or the second page if you're typing into Google Docs. It's naturally found in the Earth's atmosphere and part of the nitrogen cycle. However, human beings can add nitrous oxide to our environment. And you would say this, its levels can increase or comes from application of synthetic and organic fertilizers, burning of fuels, and as a byproduct of factories that make synthetic materials. That's a whole bunch of words for basically saying it's mostly used as a fertilizer, and we can overuse it, and the overuse of that is going to add more and more of that into our environment. And our friend the ozone layer, which we've talked about last week in class. The ozone layer, that's super important for the greenhouse effect as well. Its main purpose is going to be to shield us from ultraviolet radiation from the sun. It is also a greenhouse gas. So because ozone exists, it's able to absorb some of that thermal energy. It's going to protect us. We talked about how I like to think of the ozone layer as Captain America. He has that shield. He's physically, literally, the ozone I'm using. The ozone is a Captain America reference. The ozone layer is literally going to shield us from those dangerous ultraviolet rays. It's going to absorb that heat. Just so you know, it is made out of 3 oxygen atoms. And we, of course, know that it's located in the stratosphere. All right, so what are all these things having to do with global climate change? You've heard about it from the news, talk about it, you debate about it. Well, here's what we know, and here are the facts. Is we know that human beings have an impact on our environment, for good and for worse. We know that greenhouse gases warm the planet naturally. But we also know that if we are adding a bunch of greenhouse gases by what we're doing, well, that's not going to be a great thing because we're going to add more greenhouse gases. Those are going to trap in more heat. Therefore, our planet's going to warm up. Makes sense? So what is global climate change? It's kind of this theory that Earth's getting warmer in parts and weather patterns and systems are changing over a period of time. And like I said, we are in control of that. Okay? We can do some stuff for our environment to make it healthier, essentially, or we can continue this trend of polluting our environment, adding these greenhouse gases, warming our planet, and some bad things are going to happen and will continue to happen throughout this. So what I would like you to write down on your notes is what I'm underlining. And let's see, parts and weather patterns and systems are changing over time. So you've heard about this. We're going to study this. Super important. Cool little example. I don't know if it's cool, but it's a striking example. One of the largest glaciers in South America. You can just see the before 1928, the after 2004. Sea ice melting. And here is something that is always a kind of aha moment for young people. And I know you're taking these notes online right now, and you probably have a little bit of background, but I asked you this question. What would happen to this chart if there were fewer polar ice caps in the Arctic region? So here's what kind of I taught you today. The greenhouse effect is a good thing. It allows heat to get into the environment, warms us up. If we don't have the greenhouse effect, we're like Mars, we're cold. We're cold during the night, hot during the day. We don't have life on this planet. Greenhouse gases, well, those trap in heat. They're naturally occurring, but human beings can kind of artificially inflate those numbers in the environment. If we do that to a great extent, our planet will be warmed. So, okay, I'm sitting there and I'm trying to use Mr. Murphy as a 12-year-old boy, 7th grader knowledge right now. Okay, I'm sitting there and I'm going, okay, so I live in Ohio. Well, so what if ice melts? Well, here's kind of the problem. I know that if ice melts, sea levels are going to rise. Okay, well, again, I live in Ohio. I don't live anywhere near the ocean. Well, I ask you, what happened to this chart? Well, one of the things that reflects heat back into space are our polar ice caps. So if those go away, it starts to look like this, where I'm going to use this pinkish color here. This square would get larger. So this now becomes, I don't know, 65%. And this gets smaller. And this blue now only becomes, I don't know, what is that? 15%. The issue, guys, is kind of like this double-edged sword where, yes, sea levels are going to rise. And you're thinking, that doesn't affect me, it's in Ohio. But what it does is because there's less ice, that means that more heat's going to be absorbed and it's going to warm the planet for everyone. When we start talking about warming the planet, we talk about weather changes, we talk about um, like climate change in general, with different wind patterns and weather patterns and ocean currents. And it's something that, if I was going to explain to you, the importance of is it's something that we kind of have control over. And it's something that I care about the planet, I care about our Earth. So why don't we just make sure we're doing the right things for it? And another example, less light means less reflection, more. Is there a connection between global warming or global climate change and the ozone layer? And the answer is yes, of course there is. I'll just read this to you right now. It says the destruction of the ozone layer causes more UV radiation to enter the lower parts of the atmosphere, which actually doesn't increase the temperature of the troposphere all that much, but it does decrease the temperature of the stratosphere, causing winds to be stronger at the South Pole that can disrupt weather patterns all the way to the equator. So again, I'm using my Mr. Murphy as a 7th grader. I never understood this. And I thought, well, what happens in Antarctica certainly doesn't affect me in the Midwest. But again, another really good example, guys, of if these ice caps are continuing to melt or if the ozone layer is disrupted, that has a global effect on wind patterns. And I'm going to wrap everything up, guys, by revisiting these mini-unit goals and just kind of quickly talking over them. We will be in class working with these on Thursday and Friday, but I just want to kind of go over them once again. So what is the greenhouse effect? Well, greenhouse effect is this natural process where Earth's atmosphere is going to trap in some heat. And I'm going to draw a little picture for you just to show you. Here's the globe. Okay, cool. There's some continents. All right, sweet. There we go. Cool. There's some water. All right, cool. Well, Earth's atmosphere is like this invisible little, I don't know, shield around it, I guess. And energy from the sun is going to enter into our atmosphere. Some of it is going to bounce back into space, but some of it is going to kind of bounce back inside in our atmosphere and be trapped in there. And that trapping of heat is what the greenhouse effect is. So why is it so important? Well, without heat, we don't have a planet. We don't have an atmosphere, we don't have a planet or an atmosphere conducive for life on Earth. Think Goldilocks again. Our atmosphere is not too hot, not too cold. It is just right. So what is a greenhouse effect? What is a greenhouse gas? Excuse me. Those are gases that absorb heat. If I was going to explain it in a boring way, I'd say the greenhouse gas is a gas that absorbs infrared radiation from the sun. They trap heat. And then number 4, how can humans impact the greenhouse effect for better or for worse? We know that we are responsible for what we pollute in our atmosphere or how much pollution we add to our atmosphere. If we continue to add carbon dioxide, methane, nitrous oxide into our atmosphere through the burning of fossil fuels, well, we know that because CO2 is a greenhouse effect gas, we know that those absorb infrared radiation, trap heat. That's going to add energy in your atmosphere. So how can humans' actions impact the greenhouse effect? Well, we're in control of what we put into our atmosphere, and we can do a better job of making sure we take care of our environment. Thank you. Appreciate it. I know this was kind of long. I hope you're having a great day. Till next time. See ya.